So yeah, thanks so much for having me. So I've been keeping bees since about 2005 and working for the University of Minnesota in the United States since 2006. We have a pretty good bee lab there led by Dr. Marla Spivak, and so we do a lot of research on bee breeding, on propolis, on bee health, things like chalk brood, hygienic behavior. Like I said, our lab really focuses on finding ways to help bees keep themselves healthy, and so this ranges from looking for bees that are really good at fighting off disease like brood disease like chalk brood and AFB and EFB, all the way up to breeding for bees that collect a lot of propolis, which reduces the incidence of disease in the colony. Let's move on to the main event. So even a lot of new beekeepers who are just getting into beekeeping in the US, it takes them a couple years to get mites under control. So they often will, get a package or a nuke, and then they'll try a couple years, they'll lose their bees each winter. We get most of our losses in the winter. And then they'll start learning more about mites, and then once they get that under control, they start to have much better overwintering success and long-term colony health. And so usually when I give these talks to new beekeepers, in the United States or beekeepers learning about mites, is I just tell people mites are just a reality and you have to deal with them. So Varroa are a parasite that lives on the outside of honeybees. They are entirely dependent on honeybees, so you can't have them, they don't live freely, they're not living on flowers. There are lots of, there are other types of parasites that can live outside the colony, like hive beetle, tropolaelaps mites, but Varroa mite has to live on living honeybees. They feed on both the pupae and the adult bees. The original host is Apis cerana. So this is the life cycle of Varroa mite. This is how they reproduce. And so we're going to really drill down into this to look at these different stages to understand how the mite reproduces. So we start off with, we're in the brood nest. We've got nurse bees walking around on top of the comb, and then some of them are going to have adult Varroa mites on them. So the mite herself will be tucked up under the segments of the bee. So they're pretty hard to see. So they'll be tucked up under there, and then the mites can smell when they're over 5th instar larvae. So they know when that brood cell is about to be capped over, and they'll jump off the adult bee, wiggle themselves down underneath the larva, and then wait there until the cell is capped. And they don't want to go in too early because then they'll just get pulled out. Obviously too late, the capping is there, they can't get in. So then that foundress mite who goes in there, she is going to make a little breeding patch on the underside of the pupa. And so they actually feed preferentially on where the fat bodies are located underneath the pupa. And then she'll lay a series of eggs. And the first one is going to be a male, and then the subsequent ones after that are all her female offspring. And so then as they develop, the daughters will mate with that male mite, and then they'll keep feeding on that pupa. So one of the big danger zones, especially for us, we have a lot of issues with viruses, is at this point when the foundress mite and her offspring are feeding on the pupa, it's going to weaken the mite, or it's going to weaken the bee itself because they're eating the fat body and some of the hemolymph, so that's not good. But then they're transmitting these viruses or amplifying some viruses. And so there's a lot of evidence to show that when a pupa gets infected with viruses at that stage of her life from being bitten by a mite, it's way worse for her long term than if she gets exposed to those viruses as an adult. So this is the point, where we're really thinking about most of the damage happening in our colonies. It's not really so much those mites that are on adult bees, it's the mites that we can't see that are reproducing under the brood caps in the colony. And we'll talk about this later with treatment, but what's really tricky is that it's really hard to kill mites when they're in this stage. So most treatments are not going to penetrate the brood cap, and they're not going to do anything to that mite that's in there. So depending on what you're using, you either have to pick something that's going to work under the brood cap, or be really careful so that you're managing mites so that when they are on adult bees, you're just kind of constantly knocking them down so that you're keeping the population level low. All right, so then before that bee emerges, usually, the male mite will die off, and then some of those daughters will finish maturing, and then oftentimes at least one of them is able to be old enough and mature enough to leave the cell with that bee and then go on to infest another cell. And so usually the founder's mite, that original one, can, go in up to 4 cells. And so, and then each of her daughters can go into 4 cells, and they can reproduce really quickly. And then within the colony, we do have mites moving around from bee to bee. They can walk on the comb, they can go between bee to bee. And so there is also some transfer of viruses, as we have those adult mites moving from bee to bee. But like I said, a lot of the damage happens when it's a pupa. So if we take a look at this whole cycle, what we can see is that really, as we have colonies that grow and get bigger and stronger, that's a chance for the mites to reproduce. And so they're obviously great parasites. They're very good at what they do, but it's bad for us because things that we would do to produce a strong colony and produce lots of brood and get a colony that's big and is going to pollinate well and produce a lot of honey, unfortunately, that can really encourage the growth of Varroa if we want to have these big, healthy brood nests. And within this cycle, these I showed all worker bees in here, but if we have a lot of drone brood, they'll preferentially reproduce on the drones because they'll have a couple extra days. So instead of it being 21 days for total, from egg to emerging, it'll be 23 days. And just those couple extra days give the mites a higher rate of reproduction. And so instead of it just being, one daughter who is successful in getting out, it's a higher rate of getting closer to 2. And so the more drone brood that you have in the colony, the more successful this life cycle is going to be for the mites. So like I said, really what's happening then is if you have high mite levels in the colony, you have a lot of mites under the capping, so you have a lot of bees that are already sick by the time they come out into the colony. It really affects the long-term lifespan of the hive. And a big part of this is, like I said, these mites are transmitting viruses. And so the biggest virus that we have to deal with is something called deformed wing virus. And so if you have high levels of mites in the colony, one of the symptoms you can see is that you'll have worker bees that emerge with these shriveled little wings. And so those have a very short lifespan. They can't forage. They're pretty useless in the colony. And you'll see that on both worker bees and drone bees. But what's tricky is that this virus, you don't always see that symptom of deformed wings. So you can have high levels of deformed wing virus in the colony and not necessarily be seeing those shriveled wings. And unfortunately, there's no real good test for beekeepers to test for viral loads in their colony. And so we just have to basically use the mites as a proxy so that we're making sure that we keep the mite levels low and we're keeping the virus levels low. And like I said, if a bee gets, if she gets infected with deformed wing virus as a pupa, her lifespan is way shorter, up to 50% shorter than if she was to get infected with deformed wing virus as an adult. And so mites are just really, really great at transmitting specifically that virus as well as other viruses. The virologist that we work for has done, some interesting work where he looked at the islands of Hawaii as they started to get, when they actually got mites, which was later than the rest of the United States. And he said the mix of viruses really changed as mites moved in. And so a lot of them were viruses that were already present in the bees, but they became much worse and amplified when there were mites reproducing on the bees. So it's taking the viruses that are there and making them a lot worse. So like I said, deformed wing virus is the biggest one, but we have black queen cell virus, acute bee paralysis virus, Israeli acute paralysis virus, sac brood. And some of these are just associated with mites. They're not necessarily amplified by mites, but it's hard to tell because, other than looking for that deformed wing virus symptom, or sometimes you'll see black shiny bees from some of the other viruses, it's hard to see what's going on with the viral levels in the colony until your colony just poops out and dies. So, like I said, all we can do is we have to monitor mites and keep the levels low so that we're also monitoring those viruses. And a lot of times people in the US will think, okay, since mites are big enough to see with the naked eye, I should be able to see them if I have them. But because the mites preferentially, they really like to tuck themselves up underneath those segments on the underside of the bee. If you're seeing mites walking around on the back of the bee, it means that generally your mite levels are already quite high, and probably at that point, at least in our conditions, the colony would most likely die if you're seeing that many mites. And so it's really important for us to be monitoring and keeping track of our mite levels over time. Another thing that I often do is just kind of a casual inspection as I'm going through is, in the springtime for us, that's our big drone season. So, as colonies are getting big, when we get into swarm season, they start to make a lot of drones. And as I crack those boxes apart, there's usually like a big strip of drone brood there. And I always take a quick look and I'll flick those drone pupae and larvae out. And if I see a lot of mites on those drone pupae that I open, then I know that colony, I need to test, and I'm probably going to need to do a treatment on it. Because like I said, they're preferentially going to be on the drone brood. So especially in the spring, when they just all kind of get sucked into the drone brood. And so that's a way that, it's just kind of a forecasting tool to see if you're going to have a problem down the line. So this would be an example of a colony that has what's called parasitic mite syndrome. So this would be basically when the colony is more or less just about dead because they have really high mite levels, the colony's really sick, generally speaking they're just going to crash. And so you can see there's a lot of uncapped pupae. And if you start to see a lot of what we'd call bald brood, so these opened up pupae, then if you see a little bit of that can be a good sign, because that means they're doing what we call hygienic behavior, where the nurse bees are actually able to smell that there's something going on with that pupa, whether it's disease or they're being parasitized by a mite or the pupa is dying for some reason. And then they can uncap it and then pull that pupa out and remove it from the colony. And so they use this not just against mites, they use it against chalk brood and EFB and AFB. But if you see a little bit of that actually can be a sign that your colony, has that hygienic trait, which is something that queen breeders can breed for and select for. So that can be a good thing. But if you see a ton of it, where a lot of that brood is getting uncapped, you see chewed down brood, like that one in the middle where they're starting to chew it down and take it out, or you see, like on this one, that's a pre-pupa, so it just got capped over and now they're uncapping it. Signs of that means that there's something really wrong going on in the colony, where a lot of your brood is not healthy and they're going to have to remove it. And at some point they just can't keep up. And so oftentimes when we have colonies that collapse, there'll still be patches of dead brood that looks like this, where they were trying to remove that brood, chew it up and take it out, but the colony basically died before we got to that point. The other thing you can look for if you see symptoms like that is you can actually look for little patches of mite frass on the top of the cells. So this little white patch up here, get out of the way. It kind of looks like, a little bit like flecks of whiteout on the top of the cell, and it's going to be on the ceiling part of it. So when the foundress mite is in there, she makes a little poop patch where she and her offspring go poop, and it's like this little, these little white patches and crystals. And so if we're kind of doing an autopsy on the colony, trying to figure out why they died, one way that we can confirm that is that when we look at those cells that have been cleaned out, or we pull out some pupae ourselves, if we see those patches of white on the top, that indicates that that was a cell that was parasitized with a mite who is reproducing. And so it's one of those things, it's telling you what happened after the fact, but it's telling you, if you see a lot of that, then you know that there were lots of mites in that frame. So we use, generally speaking, 3 different methods when we're monitoring for mites. A lot of beekeepers in the United States, hobbyists, will use the powdered sugar roll, where you collect 300 bees, you shake them with powdered sugar, shake them out, and then the mites fall through the mesh, and then you shake it into a little container, spray it with water, and you can take a count of the mites. Researchers, and what we use is the alcohol wash, which I think is what you said a lot of people do here. And that's kind of the gold standard that works the best. Some beekeepers also use sticky boards, so they'll use a screen bottom board and then put a sticky board underneath. Sticky boards are nice because you don't have to be going in the colony, but it's really hard to figure out what your treatment threshold is with a sticky board. So some beekeepers use them, but what they do is they keep them on throughout the whole season, and they kind of know for their colonies as they start to see more mites on the sticky board what that means for their mite levels. And then especially if they look after they do a mite treatment, you know, they can see a big decrease or a big mite drop. The powdered sugar test, I'd say probably would not be a good option because it's really weather dependent, and if it's hot and humid and the powdered sugar gets sticky, it doesn't work very well. So honestly, there's times of the year, even for us, that it's hot in August and it doesn't work. So most of the time we just tell people to do the alcohol wash. When we do it, the goal is that what you want to do is you want to get a sample of 300 bees. 300 bees is about a half a cup of bees. So if you just take a scoop and you mark what a half a cup would be, you can just roll it down. And it seems counterintuitive that you would be rolling down. If you roll up, they kind of just get stuck between the cup and the frame. But if you roll down, they just flop over backwards. And you want to be monitoring in the brood nest. So you take a frame that's got a mix of sealed brood and open brood, because that's what the mites are going to be attracted to. Check carefully that your queen is not on it, because you don't want to sample your queen. And then, yeah, you can just quickly take that 300 bee sample and test it with either the powdered sugar or the alcohol wash. So there's a lot of ways to take the sample. The goal just is that you want to be consistent about it so that you're getting 300 bees, approximately 300 bees each time, so that you can calculate the percentage of mites that you have. Because a lot of these recommendations that you're going to get about treatment are going to say treat at a certain percentage. So for us, in the spring, most of our recommendations would be to treat at about 1 to 2% infestation. So, you know, if we have 3 or more, 3 to 6 mites in that 300 bee sample, we would be at our treatment threshold. It's also important to just make sure that you're testing again after you do any treatment, because none of the treatments that we have available none of them are 100% effective, and so they're not going to kill all the mites. Some of them will work better in different temperatures and different seasons, and so you always have to be checking again to make sure that what you actually did was working the way you think it was. We also find that in places where there's a lot of beekeepers, we have a more mite pressure, and so you have to be more vigilant about what's going on with your colony and your mites. If you have a really, you know, an apiary that's just far away from other things, or like if you had an island or something, you know, then you don't have to be quite so careful about it, because you're not getting mites coming in from other colonies after you've treated your own colony. But I mean, for us, we live in a place where there's tons of hobby beekeepers, there's commercial beekeepers moving around, and so, you know, that's not really practical for us. And like I said, yeah, none of these treatments are to like eliminate the mites, it's just always to knock them down, and then to knock them down again and knock them down again. And one thing to remember too is that once you have higher mite levels, even if you're going to kill, for example, 90% of the mites in the colony, if you already have thousands of mites in the colony, if you knock them down 90%, you still have a lot of mites. And so you want to keep them at low levels and not wait till they get high. The other thing is, for us, a lot of times what happens in the fall is that because they've already transmitted so many viruses, the damage has been done. And so even if you knock the mite levels down, you're still going to lose your colony, because they're just so sick at that point that they're not going to make it anyways. So these are the treatments that we have available, and I know that you guys have a different set of treatments available. A lot of commercial beekeepers will use Apivar, which is Amitraz. We don't use Apistan or Checkmite, which are fluvalinate and Coumaphos, because the mites are pretty much resistant to those, and so they're not effective. There are some places where they're pretty resistant to Apivar as well, but on the whole, it's a treatment that works well. Generally speaking, we try to use organic acids in our colonies. So we rely mostly on formic acid for most of the season, and then we do oxalic acid either in the early spring or in the late fall. The reason that we like formic acid is because it's one of the few treatments that actually kills mites under the brood cap, and so you're actually killing the mites that are doing that damage. You're not just killing the mites that are on the adult bees. But I think formic is available or not?
Formic's available.
Okay, yeah.
That's of course too hot.
Yes. So that's an issue with formic too, is if you treat and your colony is above 85 Fahrenheit.
25 degrees.
Thank you.
25.5, I think it is.
Okay. It can really damage your colony, and you can have queen loss. It's pretty tough on open brood. And so we tend to only use it, in spring, a little bit later. When there's no brood left in the colony, we'll do an oxalic acid dribble. So oxalic acid is not getting underneath the brood cap. And so when we get to the point where we don't have brood in the colony, then we'll do that dribble treatment. So oxalic can work really well if you, do a brood break, cage the queen, do a split or something like that. That can be a really effective treatment. With oxalic, it's pretty safe for the beekeeper to apply the liquid method. You just put it in a syringe and dribble it on top when the colony is kind of clustered down. But you do have to be really careful if you're doing the vaporizer method. You do not want to breathe in oxalic vapor. It can be really, really bad for your lungs. And so just be very careful. A lot of times we tell people to wear a fume respirator and just, make sure that you don't have people around you watching you while you do it. With a lot of these, you don't need a brood break with formic because it will kill under the brood cap, but most of these you do have to take the supers off and then leave them off for a window of time. So formic is that's another reason that we like formic, is that it doesn't affect the honey, so it is something that you can apply with honey supers on. If you're using like Apivar or Apistan, Apiguard, any of those actually can contaminate the honey, so you should not have honey supers on when you apply those treatments. And then for some of them, like Apivar, there's supposed to be a 2-week window after the 42-day treatment that you wait to put supers back on. And so that's what's tricky. I mean, we have a pretty short season. We just, have a short honey flow. And so for us, trying to time it so that we can treat for mites and then have that before and after the honey flow, we just have to, that's why we often use formic, is because it's a relatively short treatment. We can leave supers on or put them on right afterwards. And like I said, you always want to make sure that you're testing after your treatment. So especially for us in September, we have huge issues with robbing, where colonies, we have a big dearth period. They'll just start robbing each other. And if you have a hive that is collapsing from mites, they get really weak, and oftentimes they were a big colony that had big honey stores, and they are a prime target for getting robbed. And so then your bees go in, rob that honey, but then the mites will transfer onto the bees that are robbing and get brought back to other colonies. And so sometimes the treatment doesn't work. Sometimes your bees will rob. There's drift. So just make sure that you're monitoring over time. Yeah, and then like I said before, if you're trying to figure out why your colony died, you can look for signs of mites. You can look for the mite frass. You can look for the signs of those uncapped pupae. Sometimes you'll see pupae with their tongue sticking out, and that's often an indicator, if they're still in the comb, that they died from viruses, so you can look for that. Yeah, so then, just what we usually tell beekeepers in our area is that it's just really important to understand mite biology so that you have a good handle on how they reproduce, how they grow, how that's going to affect your colony life cycle, because obviously your colony life cycle is way different than what we would have in Minnesota. So just knowing, when your colonies are increasing in size, when they're decreasing, when there's a dearth, if there is ever any brood breaks, what's going on with that. And yeah, just stay updated. So I mean, when I started keeping bees and started working at the lab in 2006, our mite treatment threshold was 10%, but now it's down to 1 to 2% because we have so many more issues with viruses. And so you just have to stay updated, keep learning about what the recommendations are. There's new treatments coming out, learn the recommendations for those, and just, yeah. And so with that, I'm just gonna put up my email address, and if you'd like to email me with questions, I'm happy to talk about mites and put a link for the lab up. And then this bottom link is a really great resource for looking at different types of treatments. It's called the Honeybee Health Coalition. It has this tool where you can walk through and you can say, like, my colony is this big, they have these many supers on or not, this is what the temperature is, and then it has a tool that will say, okay, well, these would be the treatments that would be good and appropriate treatments for you, with all of the label information and how to apply them. So we use that a lot, we give that to beekeepers a lot, so I would highly recommend that one.